Hi everyone, today I want to share you about a project that I am currently working on, a command prompt for microcontrollers. So basically it's a terminal slash command prompt like interface for microcontrollers where we can add custom commands which can be called at runtime. Example, say if we want to change device SSID or password, that can be done by just running a command, or reading, or say you need to read some sensor data. It currently works over UART. I implemented it as a header only library, and it's compatible with Linux, Raspberry Pi, Pico, Arduino and ESP32. Think of it as a shell for your microcontroller. As you can see in the picture on the right hand side, it's a shell for your microcontroller. You can find the blog post and the source code in the below URLs. Now it's demo time. On my right hand side you can see I have opened my serial terminal GitHub page, and on the left hand side I have opened a project that I'm currently working on. So where I want to include this header, this feature, serial terminal. First thing what I have to do is I need to copy this serial prompt.h, as you can see from here, to my project. So I've copied it already. So this is the header file, and next what we have to do is we have to add some macros for it to work. So first thing, we need to define the print and read functions that our framework is currently providing. Currently I am using Arduino framework for this ESP32. There is a serial print and serial read that the Arduino framework provides to print to the serial and to read from the serial. So I need to define these two macros. Then I need to include this header file, serial prompt, that we have just included. The third step will be implementing our commands. So what we have to do is our commands has to be in a format, in a specific format. This is the command name. The command must include two types of arguments. One is the number of arguments, and next is list of arguments. So here what I have done is I have just implemented a multiply handler. It will take two integers from these two arguments and it will multiply, and it will print on the serial terminal. The first step, we need to add our multiply handler or the callback function to this command list. Here the format is mult, the function name, this is the description, and this is the handler. We can add multiple commands to this list by just appending a comma to the end and copying the new command handler to this list. So now I have just implemented a command, a mult command, so I'll be not adding extra things. Next, now the fourth step is done. We need to just call the serial grid. It will just print this hello from serial prompt. There will be type question mark for help, and this is the prompt. Next, from the loop we need to continuously call serial run so that it will always keep reading from the serial terminal. So let me show you. Let me compile this code first. So I'm using platform.io to build my project. Now the compilation is successful. Let me upload the code to my ESP32. Great, it's successful. Let me monitor. Let me log into the device. You can see, right? There is a command like interface here. Hello from serial prompt, type question mark for help. If we just type question mark, it will show all the commands that are available. It will show this is the mult command and this is the description. So mult will take two arguments, num1 and num2. Let's try it. Mult 2 and 4, we should give 8. Great. There is also a feature that I have recently added. Suppose you mistype the command, you can just type backspace and type the command again, this time 5, and it will work. So this is the demo. So let's now jump in how it works. So the main read and write loop is this serial run. Let's jump into the definition. Here there is a function called read until that reads strings from the serial prompt until a new line is reached. Then a tokenizer is called. The job of tokenizer is to break the string, the line, into tokens. So this is suppose this is a line, the tokenizer will break into multiple array of characters. One will be mult, one will be 2, and one will be 4. One will be 5. Then we will take the first string that will be mult, and this we will search against the registration table that we have. So we will try to find that token, the first token, if it is present in our command list. If it is present, if it is greater than -1, then we will call the handler that we have previously registered. We'll call this handler that was previously registered with us, and we will call that handler passing the number of arguments and the tokenized buffer, like this array of string will pass to that handler. The handler then will check if the number of argument passed to it is proper or not, then it will do the computation and it will print. Now let me talk more about on the functions read until. So what it does is it just reads from the terminal character by character, and it handles the backspace, and it will print the character, and it will store in the string. Here it is storing in the string until a new line character is reached. So basically we are reading the string into this buffer character by character until a new line is reached. And this is the tokenized function. What it will do is it will break the line that we have currently read from into the buffer into tokens separated by spaces. So next, the find command. It will iterate through the list of commands that we have already registered. It will compare the command that we have passed with the already registered command name, and it will return the index of that command. Otherwise -1 is returned. Print help is just to print all the commands name with their description, and that's it. That's how basically this library works. You can find the source code for the serial terminal in my GitHub repo, or you can follow the blog post in hexter.io. Both of the links I will provide in the description below. So thank you for watching. See you next time.